Welcome to fourth lecture in our IoT series. In this video, we'll be looking into actuators topic. So we'll understand what actuators are, what are the different types of actuators, what is the working principle and characteristics of actuators. By the end of the video, we'll have a strong understanding of how actuators actually work and uh, everything related to actuators. So I would suggest you to refer the previous videos in which we have discussed about various concepts and then get back to this video. So let's start now. So let's start with the definition of actuator. Actuator is a device that converts electrical signals into physical action, typically in form of motion. We know that sensors are used to convert the environmental factors into electrical signals, right? Now these electrical signals have to be further converted into some action. So the apparatus which is used to convert it into some action is called as actuator. Okay, so it is essential in systems where control over environment or machine is required, like adjusting position of valves, motors, or any mechanical system. Let's look into the key aspects. Okay, first one we have is control system interaction. So actuators are connected to the control system, so which will send instructions like what to do, what action to be taken, and all of that. Then we have analog or digital signals. So the control signal sent to the actuator can be either analog, that is continuous signals, or discrete, that is digital signals. Then we have physical motion. Physical motion means the response from the actuator is usually some sort of action or physical motion. It could be like mechanical motion, like rotation of a wheel, or linear motion, or gripping, or any other examples. Now let's see some commercially available actuators used for IoT based control applications. So the first one we have is brushless DC motor. So this is used in high efficiency motors with precise speed control. So we can find DC brushless DC motor being used in drones or electrical vehicles, it is also used in robots, industrial robots, and all of that. Then we have stepper motor. Stepper motor is used for precise positioning in discrete steps. So it is used in 3D printers or camera sliders or robotic CNC machines and all of that. Then we have is geared stepper motor. Stepper motor with increased torque via gears. That is addition. Here we have gears. Okay. So it is again used in robotic arms, conveyor belts, and all of that. Then we have DC motor. DC motor is used for converting electrical energy into mechanical energy. This best example is fans, electrical fans we can see. Next we have is hydroelectric generator. Hydroelectric generator converts water flow to electrical energy. So this is used in dams, okay, or hydropower plant. We have relay array. Relay array is array of relays to control multiple high power circuits. This is used in home automation usually, home automation or industrial control systems and all of that. Then we have DPDT switch. DPDT switch is used for controlling two circuits used for reversing polarity or switching purpose. Then we have push button. Push button is to make it active or inactive. We use this everywhere in most of the IoT projects. We must have used that. We have solenoid flow valve. It is used to regulate the flow using electromagnetic control. Hydroelectric generator, again to generate only. It is both the diagrams are same. Here also it is same. So these are commonly available, the commercially available actuators. Moving on further, here we have simple actuation mechanism. So firstly we have monitoring here. Monitoring we'll have use. Okay, let me write it. First step is monitoring. From monitoring, we have user commands. So the process begins with a remote user who will provide input or commands through this monitor. Okay. So this input is usually digital signal, and this digital signal will tell what action to be performed. Okay. Next step is we have processing here. So in processing, the sensor node is there. So we have control system here and command generation. So in processing, we have control system firstly, also called as processor, and along with that, we also have command generation. So in control system, user commands are received by the control system. After that, it will convert it into high level user input or machine readable code, and then give the instructions to the motor driven mechanism. Okay. Then command generation, that is these instructions are then sent to the actuator, like motor driven mechanism. Both are approximately both are same. Okay. Now that we have reached to the third step, the actuation process. Here we have motor driven mechanism. So the actuator, suppose let's take it's a robotic arm. Okay. So it receives the instruction from processor, and after receiving the instruction, it will perform the action. Suppose if the robotic arm has to pick up a box on a conveyor belt, or if it's, let's say here it is factory automation, right? So in factories, robotic arms are used in a large number. So whatever the action is specified, that action would be performed. Then yeah, that motor, that mechanism or mechanical action would be performed. Next we have is environment. So um, once the boxes are picked, so and so action is performed in the environment. That is, our ultimate aim or goal is achieved here. Right. So majorly speaking, we come across processors. We come across the role of processor and the role of actuator. Processor will translate the user commands into actionable machine instructions, and actuator role is to convert those instructions into action or the mechanical action or moving objects. So this was about the simple actuation mechanism. Moving further, we have actuator types. So actuators are devices, we know they are used to convert electrical energy into mechanical motion. So they play a major role when it comes like performing tasks like opening the valves or moving objects, switching system on and off, and all of that. We have seen that in the examples, the types of actuators above, right? Now we'll look into the types here. Okay, so if I have to read out the types, first we have is hydraulic, pneumatic, electrical, thermal or magnetic, soft, mechanical, and shape memory, polymer. So let's start, or let's discuss them one by one. First one we have is hydraulic actuators. So hydraulic actuators are, they used compression and decompression of liquids. Okay, they work on compression and decompression principle. Okay, to create mechanical motion. They use compression and decompression of liquids to create mechanical motion. You can say that hydraulic power, conversion of hydraulic power to mechanical power is happening here. Okay. So the motion type here could be linear, rotary, or oscillatory. One of the key feature is that due to incompressibility of liquids, hydraulic actuators are capable of exerting significant force. Like they are also known for their high force output. Also famous for their high force output. If we have to speak of examples, we have almost all of us have used hydraulic lifts, right? So this is one of the major examples where heavy duty machinery or heavy tasks are done easily by making use of hydraulic power. Okay. Next, moving on further, we have pneumatic actuators. So pneumatic actuators rely on compression and decompression of gases. Previously, it was compression and decompression of liquids, right? Here it is compression and decompression of gases. And convert it into motion or mechanical action. So the motion type or the generated motion here could be linear or rotary. Next, like these pneumatic actuators are classified as compliant systems. That is, they can respond quickly to smallest changes in the pressure, also called as compliant systems, as they can to smallest respond quickly to smallest changes in pressure. They are also famous for quick response, that is to the start or stop commands. So small pressure changes can generate large forces. Example could be the pneumatic brakes, which are used in vehicles. So once you put pressure, a little bit pressure on the brake, even the huge vehicle which is moving with particular speed stops, right? So this could be a best example to explain the pneumatic actuators. Next we have as the electric actuators. So electrical actuators have the working principle is that they make use of electrical motors to convert electrical energy into mechanical motion. So here the best thing is they are considered as cheapest, cleanest and fastest actuator. Compared to all the other actuators, these are the best ones. They are mostly used in solenoid valves. Solenoid valves are used to control flow of liquids depending on the electrical signals. Next, speaking of the example, here the best example, one more example is stepper motor. So stepper motor is used in like most of the IoT based control systems, like mostly used in all IoT based control systems. So it could be the 3D printers, or it could be the CNC machines, robots, camera sliders, and so on. So next we have the next type of actuator we have is called thermal or magnetic. So these actuators convert the thermal or magnetic energy into motion. Convert thermal or magnetic energy into mechanical motion. So they have very high power density. High power density means they can deliver a lot of power for even for a compact size also they can deliver a lot of power. Then these actuators are lightweight and cost effective. Thus they are suitable for many IoT applications. Examples could be shape memory materials or alloys, which like they change their shape when they are exposed to heat or magnetic fields. Here they need not require electricity. Okay, so we must have come across shape memory alloys, right? We must have studied this. So these types of actuators, they don't require energy. Thus, they can work in various environments, including those with the liquids or gases also can work here. Next we have is mechanical actuators. So the rotary motion of actuator is converted into linear motion. Rotary motion is converted into linear motion here. Here we make use of mechanical components like there could be gears or pulleys, or we can make use of chains and all, right? These actuators can work in combination with They work in combination with hydraulic, electrical, and many other actuators. So common example is rack and pinion mechanism, where a rotating gear, that's called a pinion, rotating gear moves a linear rack, converting the rotatory motion into linear motion. Then like they are used, or we can also speak of hydroelectric power generators. So here when the turbine rotates, the rotating motion is converted into electrical energy. So this is one more example. Next we have is soft actuators. The next type of actuator is soft actuators. So soft actuators make use of elastomeric polymers. So these actuators are elastomeric polymers. They are flexible materials embedded into soft structures like cloth or paper, which are embedded into soft materials, which are soft materials. They are embedded into paper or cloth. So microscopic or macroscopic motions, even the small molecular level changes are very visible here, and they provide a tangible motion. So they are commonly used for precise and gentle movements. They are widely used in robot assisted surgeries, or they are also used in agricultural fruit harvesting, where not just the mechanical motion, but then they have to be very careful while dealing with, when we speak of surgeries, while dealing with a human body, we have to be very careful, right? When we make use of hard or rough substances, it is not feasible here. Thus we have to make use of materials which are very soft, right? So those are called as elastomeric polymers. Okay, then speaking of agricultural fruit harvesting, again when we are dealing with fruits, we have to be very fragile, right? Or else the fruit might get damaged. So they are designed to manipulate the soft materials and are used in many of these ways. So these are very precise and flexible depending on the action or the control which needs to be performed. Next we have is shape memory polymers. Shape memory polymers change their shape in response to any external stimuli. Change the shape depending on external stimuli. External stimuli could be the heat or any light or any pressure or magnetic field, and revert to their actual state when stimulus is removed. So speaking of the key features, they are biocompatible, they have high strain recovery, stress strain, so they have high strain recovery, and they are biodegradable. So in this we also have a concept of light activated polymers. So these are sub category of shape memory polymers. So these change their shape depending on specific light frequencies. light frequency, or we can say light intensity, they change the shape. So they can be used without any physical contact also. Speaking of examples, they are used in robotics. They are used for developing muscles in artificial limbs. So when exposed to light or heat, the polymers can mimic the contraction and exposure of muscles. That's how they work here, right? Next topic which we come across is the actuator characteristics. So actuator characteristics plays a very important role when we are selecting a particular actuator. So here majorly we have four characteristics. First one is the weight, power rating, torque to weight ratio, and stiffness or compliance. Let's discuss these one by one. So the first one which we come across is weight, actuator weight. So the physical weight of actuator directly influences physical weight directly influences its application. So when we are speaking in terms of industrial applications, heavier actuators are preferred. Actuators are preferred because there is no mobility required here, right? They need not be moved, and along with that, they provide high force and durability, so they can be installed there. Speaking of lightweight actuators, which are used in drones and all, and speaking of drones, we require lightweight and compact actuators. Then again, we have a special case, that is in aircraft landing, gas and engine motors are heavy but used in moving system, that is flight. So this was about weight. So depending on the application which you are taking, the weight plays a significant role. If it is for drones or things where mobility plays a major role, then it has to be lightweight and compact. When we speak of big applications where mobility is not required, then we go with the heavier actuators. Right. Next characteristic we have is the power rating. So power rating of actuator indicates amount of electrical power it can safely handle, both in terms of minimum and maximum operating power. So it includes minimum and maximum operating power. So it is like mostly expressed as power to weight ratio. We have power to weight ratio. Actuator with high power rating can handle more demanding application. That is, we understand high power rating means can handle more demanding application. Whereas when it has low power rating, it is used for smaller or portable systems or applications. So looking at the examples we have for small actuators, we can speak of the servo motor, which all of us might have used in our projects, right? So the power rating for this is 500 milliamperes, which is very small. We can make use in building any projects, small projects. Okay, it is very much constrained. Whereas when we speak of large actuators, again a servo motor with 25 ampere can be used. This will require a separate power resource, which is this can be used in factories and all. This is used in projects. Then again, we can also speak about the electrical vehicles. They also require large amount of power, right? Next characteristic we have is torque to weight ratio. So this ratio will tell how much torque one actuator can generate relative to its weight. let me write it down, how much torque, or it is also called as force, an actuator can generate relative to its weight. So we can say that this ratio indicates that actuator can exert more force without actually being heavy. So this type of situation, or the torque to weight ratio, is useful when we are dealing with applications where both power should be high and it should be lightweight. In such conditions, torque to weight characteristic is this ratio is considered, or it is very important. Looking at examples, in case of high ratio, we can speak about the brushless DC motor. So which is, these motors are used in drones. This will have high torque to weight ratio. That is, it will allow to easily lift, and not just that, it will also help us to monitor the movement of that drone without adding much weight to the drone structure. Then speaking of low ratio, we can take a heavy duty industrial hydraulic actuator. Industrial hydraulic actuator, which is used in construction equipment, for example. So if you see about the construction equipment, this can generate a large force, but it is not that efficient. That is, it is not light, right? So this is one example. This is one more example. Next, moving on further, we come across stiffness and compliance. Let's look into these one by one. So stiffness means actuator's resistance to deformation when a particular force is applied. So this means the resistance of actuator to deformation when force is applied. So we can say that those actuators which are stiff are more control, or they offer more control, and they are more they are having more precision because they resist movements under load. Okay, when we speak of compliance, this is opposite of actuators. That is how easily actuator can deform when force is applied. So speaking of compliance systems, they are more flexible and they can absorb shocks or accommodate changes in load easily. Looking at the examples, if we have to speak of the stiff actuators, we can take hydraulic actuators. So these hydraulic actuators, they will have precise control, and they are mostly used in robots where accuracy plays a very important role. For example, speaking of robotic arms, accuracy matters a lot there, right? Then we have compliance actuators here. Let's see the example. Compliance actuators, we can speak of the pneumatic actuators. So pneumatic actuators are more flexible and they can adapt to changes in the pressure. That is, it will be useful for situations where we apply less pressure and a large action should happen. That is, again, as we spoke about the brake systems in our cars and all, even if I apply little pressure, the entire car has to stop. So this was all about the characteristics. We have discussed all the characteristics and we have spoken about the actuator types. We saw a simple actuation mechanism. We discussed the commonly available actuators, and we looked into definition of actuators. So this is the end of the video. If you have any doubts, do let me know in the comments, and stay tuned to my channel. Further videos would be updated soon. Thank you.